So I'm Annaliese Mason, and I'm the Professor for Plant Breeding at the University of Bonn, and I'm an Associate Member in PhenoRob. We have a kind of central or core theme, which is related to polyploidy and hybridization for crop improvement. But this is quite a kind of a technical thing, so I have to kind of explain what polyploidy and hybridization are. But I won't do this. I'll just say that we're working on using wild relatives of crops and some processes by which plants evolve to fill different evolutionary environmental niches to build better, more resilient crops. So the aim of the grant is to address a particular problem related to the development of a new type of hybrid breeding. So hybrid breeding is when we bring two different parent lines together, and then their progeny, their offspring, their children or whatever, have better traits, so better vigor. They maybe have more yield, if we're talking about plants, than the parent plants do. And this process is responsible for quite large yield increases worldwide in lots of crops. So on average, about 15% yield increase comes from this hybrid breeding approach. So what I think is that we can go to the next level with hybrid breeding using these so-called polyploids, which have extra copies of each chromosome in their genomes. And having these extra copies of the chromosomes means we can potentially combine more parents together in one plant. So up to 4 parents for a hybrid instead of 2. And this would potentially then give us an extra boost to this hybrid breeding effect. But the problem is these hybrids are unstable. So when we try and make them, they have problems with fertility, and they kind of fall apart genomically after a few generations. So we want to address with the ERC consolidator this particular problem and therefore enable this double hybrid breeding. Actually, what I like the most is the chance to have these interdisciplinary collaborations. So we have in the cluster, people who work in computer science, in engineering, then there's the plant science people and the agronomists. And I think that this combination really allows you to tackle problems from totally different perspectives. So we're trying now to integrate some of the computer science, the vision, image analysis work into our plant phenotyping. So we want to try and score traits on the crops in the field. And instead of doing this just by hand, pulling out the ruler, we can actually go to the image analysis guys and say hey, we really would like to be able to extract this data from these images. And they're really experts at this. So I think bringing all of these people with different expertise together is for me a really major highlight, and it makes you think about new research directions that weren't possible before.